Okay, ladies and gentlemen, welcome to the second of three videos for Chapter 4, Section 2 in your McGraw-Hill Geometry textbooks. Again, we're talking angle sum theorem for triangles, and in this particular case, we're looking at additional examples of that theorem, how to use it in practice. Okay. Now here we have a relatively complex multiple angle problem where we're asked to find the measure of each numbered angle, which would be 4, 5, 6, 7, and 9 in this picture. Now again, when we do a problem like this, we may not be able to go in numerical order. In fact, in this picture, there is only one angle that we are able to find right away, and that is the measure of angle 7. So step 1, we find the measure of angle 7, which we do using the angle sum theorem for triangles based on triangle XYZ. That is the only angle in this picture, angle 7, that we have enough information to find. The three angles in that triangle, X, Y, and Z, are angle 7, which we don't know, 58 degrees, and 65 degrees. Those three angles must add up to 180 degrees. Now we've done a couple problems like this, so again we should know the basic steps by now. We add 58 and 65 together to give us 123 degrees. Then we subtract 123 degrees from each side to get that angle 7 is 57 degrees. Now, once we've found the measure of angle 7, several of the other angles are extremely easy to find, particularly the measure of angle 5. We can simply apply the vertical angle theorem to state that the measure of angle 5 is equal to the measure of angle 7, so it is also 57 degrees. That should not require any extra work. We should just be able to pretty much go, oh, well, that's vertical, so those are equal. We also can quickly find the measure of angle 6 now based on the supplement theorem, which says that the measure of angle 6 plus the measure of angle 7, which is 57 degrees, equals 180 degrees. So then we would subtract the measure, or 57 degrees from each side, and we would get that the measure of angle 6 is 123 degrees. Okay. Now, that leaves angle 4 and angle 9, so we'll do angle 4 next. Again, I'm trying to keep the work relatively organized here in the limited space. So far we've done 3 angles, 1 first, then 5, then 6. So for the measure of angle 4, we're going to use the angle sum theorem again. This time on triangle VXW, which we now know 2 of those 3 angles. So we can say the measure of angle 4 plus the measure of angle 5, which is 57 degrees, plus the measure of angle VWX, which is marked as being 67 degrees, equals 180. Add like terms, 57 and 67 together, giving us the measure of angle 4 plus, what is that, 124 degrees, equals 180. Subtract 124 from each side, gives us 56 degrees for the measure of angle 4. Okay, that just leaves the measure of angle 9. This one can be a little bit tricky, but not really. If we look at the markings here in the picture, we have angle markings on angles XZW and XWZ that mark both of those angles as being the same angle, which means whatever the measure of angle 9 is both of those angles. So we can use the angle sum theorem again for the measure of angle 9. Based on triangle WXZ, we can say the measure of angle 9 plus the measure of angle 9 plus the measure of angle 6, which is 123 degrees, equals 180. Now we can do two steps at once. Again, we can combine our two variables and we can move the 123 to the other side, which would give us 2 times the measure of angle 9 equals 57 degrees. Then we just simply need to divide both sides by 2, which does give us a decimal, but it's a workable number. The measure of angle 9 is 57 divided by 2, which is 28.5 degrees. Which would be the measure of both of these angles. Okay, so that was a rather advanced example. Again, we didn't do that one in class, but I promised that I would post a video of it. So there it is on the video. Now let's look at some SAT style questions based on this theorem. Okay, so here we have two SAT style questions. The top question says, in the triangle to the right, A is 34. So A is a 34-degree angle. It says, what is the value of B plus C? This should be an extremely quick question because, again, the angle sum theorem tells us that A plus B plus C equals 180 degrees. If A is 34 and we're asked what is B plus C, that should be as simple as us moving the 34 by subtracting 34 from each side of the equation, which would give us B plus C is 146 degrees. And we would be done. Now, in example 5 does not use the same picture. It says in triangle ABC, the measure of angle A is 50 degrees. If triangle ABC is isosceles, which of the following is not a possible measure of angle B? Now, I will admit that this one does use another rule that we have not talked about yet. But essentially, if we're looking at triangle ABC being isosceles, there's only two different pictures we really need to consider. Okay? We already know that angle A is a 50-degree angle. That's given in the problem. Either AB and BC are the same, or AB and AC are the same. It's worth noting that it would be the same picture if BC and AC were the same as, the picture down there to the right. That would be the same picture. Okay? So, essentially, there's a rule called the Isosceles triangle theorem that says if this is a 50-degree angle and these two sides are congruent, see how they're opposite, these two angles? That means that these two angles have to be congruent, which would make this a 50-degree angle. If those are both 50, this angle would have to be 80. So right there, that rules out these two as being possible answers, because clearly if one angle is 50 degrees, then it's possible for the other angle to be 50 and 80. And it still would be isosceles. Now, in the other picture here, you'll notice that the angles that are congruent are actually not the 50-degree angle. They're the other two angles. Well, in that case, if we call those x, then x plus 50 would be 180, meaning that 2x would equal 130, and x would be 65 degrees, which means that these two angles would each be 65 degrees, that one and that one. Meaning that 65 degrees is also a possibility, leaving 100 degrees as the only possible angle that it could not be. Okay, that does it for our second video. We have one video to go in this section that will cover the exterior angle theorem. Thank you very much for your attention.